Hey folks, in this video we're going to do another example from the homework. Here the one about marbles in a bag, and let's get to it. In this first part we have a bag with 3 green marbles, 6 blue marbles, and 10 red marbles. So how many marbles total are there? That's a total of 19, right? And notice they're asking about a probability, but they're saying that if a marble is drawn, then it is replaced. So they are taking the marble, giving it a look over, and then putting it back in the bag. So this is with replacement. Now we want the probability of getting a green marble, then a red marble with replacement. Since there are a total of 19 marbles and 3 are green, that is the probability of getting the green marble first. And the marble is replaced, so there's still 19 marbles in the bag, and now there's 10 marbles that are red available to be selected. So here we will multiply these to get our probability. I can type 3 divided by 19 times 10 over 19 to get 0.0831 approximately. So a note to make here is that because the sampling was done with replacement, that these 2 marbles were independent because the selection of one did not influence the probability of the next one. That's going to change in a next example. Okay, let's look at the second part. In a number guessing game, you ask a person to simply guess a number between 1 and 10. If the person makes a random guess, what's the probability their guess will be less than 3? So I'm assuming they're talking about whole numbers here. So if they're saying less than 3, then that would be the person either saying a 2 or a 1, right? 2 or 1. Maybe I should say 2 or 1. So there's only 2 possibilities out of the 10 that this person could say, assuming that they're only saying whole numbers. Here, this is an illustration of the addition rule. Because maybe I skipped a step, but the probability for 2, someone saying the number 2, that was 1 out of 10. And the probability that they said 1 was also 1 out of 10, and that's how you get 2 out of 10. Awesome. Last, not least, we got our bag again with a bag of marbles. 10 are red, 3 are blue, and 6 are yellow. But this time, the selection of the marble will not be replaced. Not replaced. So this is selection without replacement. And that's going to make it quite a bit different from this first one that we did. Again though, let's count up how many marbles total there are. It appears there are 19 again. And we want the probability of a yellow marble, then a blue marble. So probability of yellow, and then blue. Okay, we know that there are 19 marbles to work with from the beginning, and 6 of them are yellow. Now, a second marble is being chosen, but that yellow marble has been thrown out the window. So there is no longer 19 marbles in the mix. There is now 18 marbles in the mix. That's this without replacement business. But how many of those 18 are blue? 3. So here, I think I can do this without the help of a calculator. We have 6 times 3 is 18 over 19 times 18. And if you notice, the 18s cancel, leaving a 1 over 19 as the answer. The main point with this last problem here is that this was conditional probability. Conditional probability. So not independent, because selecting the yellow marble and not replacing it affected the probability of that blue marble being chosen, namely with that denominator right there, that 18. Let's go type these in and see how we did. Our first answer, 0.0831. Our second answer, I believe I can type that in as a fraction, but I also know that's a 0.2. And I will type 1 out of 19 for the last one. Another swath of green check marks. Feels good. Hope this helps.